All right, welcome everyone for our next speaker. This is Nicolas Carlo. Nicolas has been an active member of Legacy Codebase community for a while, and he and I had similar ideas last year to host virtual events, and he's been doing his much more frequently than MenderCon has happened, and the videos for his events is Socrates. Is that how you pronounce it? I always pronounce it wrong.
Legacy of Socrates. I will put the link in the chat if you want to look at the videos.
Okay. Yeah. So check that out. There's lots of great content, and then Nicolas's blog is also a great resource. So enjoy watching him speak, and thanks a bunch for being here.
Thank you, Scott. Thank you. Yeah. Hi, everyone. I've met with some of you, and I also know a lot of you. And for the ones I don't know yet, well, welcome to this session. Yeah, I'm here to share with you different techniques to work with the Legacy Codebase. So these are more like tips and tricks I want to share with you. And before jumping in, I am sharing with you the link to the slides. So in case you want to follow on your site or download them from later, you will have access to all the links with this. All right, so 7 techniques to tame a legacy code base. First of all, I need to define what I mean by legacy code, because you probably know that many people have different meanings for that. And when I say legacy code here, I mean profitable code you're afraid to change. And these two concepts are important. Profitable code. So here I'm talking about code that pays for your salary. It means that you cannot just throw it away and replace it with something new. You should be mindful. Some people might be working on non-profit code, so valuable code may be a better word, but I like to insist on the profitable code because I suspect that you're paid for working with existing code. And of course, you're afraid to change is a big part of it, probably because it is not tested, but not only. I've seen code that is tested and still we are afraid to change it. I also think that there is a subjectivity here. Some code may be scary today, but the more you work with it, the less scary it becomes, or the more techniques you know, the less scary it becomes. And then, yeah, it's not that legacy anymore, is it? Or for someone else who's joining, no, it feels legacy, and you have this subjectivity that matters. Here is a screenshot of you working with your code base. And why are you afraid to change this code? Usually, in my experience, for many different reasons, but the main reasons are missing documentation. And when I say missing documentation, I mean knowledge is lost. The people who wrote the code are gone. There is no test, or at least the part you need to change, of course, is not tested. And you cannot just take 6 months to refactor everything because you have short deadlines. You need to ship values constantly for people, for the business, etc. So when you're in such a situation, most people, they will resort to their comfort zone, which is totally fine. Like, you need to ship things. But if you don't know techniques to help you work with this, you will never make it better. And eventually, yeah, you will burn out or you will be burned. So my name is Nicolas. I work as a tech lead in a startup in Montreal called BuzzBud. Interesting because it's a startup, and yet it has been 10 years out there, and the people who wrote the code are long gone. So I'm working with code that no one in the company remembers it's coming from. It's mostly JavaScript and TypeScript, so no type system to help us. So interesting challenges. And as Scott mentioned, I also blog frequently on andersonlegacykode.com. Here are the 7 techniques, and we'll dive right into the first one, which is ADRs. So ADR stands for Architecture Decision Reports. It is the kind of documentation that doesn't suck, I would like to say. No, but really it's a specific kind of a documentation. The goal here is not to say what the code, what the system is doing, and that should be always true, evergreen, which is very hard to do. Instead, here, what we aim to do is to provide context. So later, when we wonder why is this working like that, we may have an answer here. Very often we lose knowledge because we took decision verbally when like people are smart and they do things to solve problems, and so they don't do something just because they are mean. But in the future, that decision may look weird or dumb. The problem is you don't really know why this was taken. So an ADR is a way to simply capture that context so later you can remember it. And the good thing is you cannot be wrong. Like anytime you add an ADR, it's just added value. There is no problem in making too much of it. Here is an example from the code base I'm working on, written a year ago by a developer who is not here anymore. And yeah, the decision here was that we will stop reading the data from the main database. So first you have a title, then very important, you have the context. Context is everything that makes you take that decision. It may be technological constraint, business constraint, knowledge, what you know today, what you're familiar with, what the team is familiar with, what you can or cannot do, anything that explains that you are taking this decision instead of another. Then you have the decision in itself, which is more or less the title with a little bit more details. And finally, the consequences. So usually when you take a decision to achieve something, you can document that here. Eventually, you may have other benefits or cons of taking that decision. Some things may be harder to do after you take that decision. And it's a good thing to list all of the things you can think about already. Maybe you won't think about everything, that's fine. But at least you say that you understand the compromise and this is why. We're not the only ones to do that. There are many people out there. Here's an example from the UK Ministry of Justice. So they keep, ADRs along the code. These are markdown files, very simple documents, so no need to do something fancy. Make it easy to write and put them just along the code. So the next time you are looking for something in the code base, maybe you will find the answer in one of the ADR. Writing them is quite easy, and there is even a CLI tool you can use that generates the whole boilerplate for you. So you just really need to fill the blanks and that's it. And you can even supersede a previous decision. Sometimes you take a decision and then 1 year later the context has changed, and then you can take another decision and you can link them together. So when you go and read the decision again, you can find all of the other linked decisions. But really, it is that simple. And I encourage you to start writing that. Try it out. Actually, here I'm presenting 7 techniques, and they're really different. That's intentional. I want to provide you with a buffet selection of things you can try out. Some things you may know already, some things you may not. The idea is that you find some technique that is intriguing to you and you try that at work. Let's move to the second technique. I call this one the brain dump. And here is a fact. Our short-term memory is limited. We know that we cannot remember so many things at once. So according to studies, it's approximately 7 items at once. And there are techniques to overcome this, like chunking, for example. If I give you my phone number, I won't give you every single digit. I will give you 3 or 5 chunks that you are more likely to remember. When you're working with existing code, it is very easy to get distracted because you want to do one thing, and then you open the box, you dive into the code, and many things are jumping at you. You discover how the thing is working, and you will see plenty of things you don't really like, things that are not really great. And it clutters your brain, basically. It makes it harder for you to stay focused, and it makes it easier for you to get distracted or to forget about what you were doing in the first place. The idea is, we're in 2021. What if we could use a second brain, to dump all of this information that is coming to us? And so we dump this information here so we can stay focused and forget about this. And then later, when the time is right, we can tap into that storage and pick the next big thing that is accurate to tackle. In 2021, this technology exists, and this is a technology I call PNP. It stands for pen and paper. And yeah, I am trolling a little bit, and you may be wondering if I just advise you to take notes as one of my techniques. And the answer is yes, but it's not just that. I like to think about this like meditation. It's common sense. Anyone can meditate. The question is, can you meditate? You see, it takes practice. Anyone can do it. The question is, are you doing it properly? And having a pen and a paper is not enough. The practice here, the trick here is, how do you use that pen and paper to stay focused and do one thing? And here is how I do it, how I recommend doing it. So yeah, always have pen and paper next to you. I do have that. What I like to do is I write down the one thing I'm trying to achieve. And then I dive into the code and I will find plenty of things I will discover. And any thought that I get that will distract me from doing this, instead of keeping it in my head, I will take my pen and write it down. That has two effects. First, my brain calms down because I know that I won't forget about this. It is written on my paper. I can get back to it later. Calm down. Just get back to what you were doing. And then when I'm done, I cross off what I was doing and I can evaluate what's next. And that I found that really efficient to avoid the tunnel effect of you get caught into, oh, while I'm doing this, I will also do that, and then this, and then this, and then nothing is working. And next time, like next thing you remember is you're at stand-up and saying, I'm almost done, I think, but it's the third day in a row that you're telling that to your team. Next technique is, I call that overcommitting in purpose. You may know that as micro-committing. I want to call that overcommitting because the trick is we're not committing enough. You probably know that. I want you to commit more often, and then even more, like absurdly often. Especially at the beginning, it will feel absurd how often or small the commits you will have to do. But at the end of the day, it's a great habit to take. So I don't know how you feel about committing, but what if I tell you commit every 5 minutes? Or every 2 minutes, or every minute, or at every change you do? How does it feel? Probably a little bit stupid because it's not about a matter of time, but it's about the habit of reaching out to the command line or Git GUI, whatever, and doing a commit of what you did, like stopping and doing a small commit of one little thing. Usually we get, caught in the code and doing one thing or maybe many things, and we forget to commit. And at the end of the day, we have a big commit we don't really know how to untangle. The way I'm doing it, and with really any habit I want to take, like drinking more water, I take a gym timer like this. I put the picture on the slide. I really like this because it will buzz in my pocket every 5 minutes, for example, for an hour. And it's really nice that it only buzzes because it won't stop me. I will stay focused, but I will get a little reminder of, hey, should you commit? And then every 5 minutes, I will go and see, yeah, actually, I do have something I can commit. And yeah, with practice, it becomes a habit. And here is an example from a few months ago. I don't really use it anymore. I realized that naturally now, when I'm working and doing refactorings, etc., whatever, I would produce 1,000 commits within 10 minutes, like this. And I don't really pay attention to it. It has become a habit to do smaller, tiny commits. And the biggest payoff I find is with my coworkers. I try to keep my PR small, so it's easier to review for my peers, but someday I got a PR that was bigger than I used to. And I complained, and my coworker told me, no worries about the size of your PR because your changes usually are hard to follow. Your commits are very well organized. I say, thank you. I don't reorganize my commits that much, actually. It's not like I was trimming my commit history. And it's not really that they are well organized, it's that they are so small that I realized my peers, some of my peers, they review my PRs commit by commit because it's easy to follow what I did step by step. So I encourage you to try that, like for 1 hour, for example, and see how it goes. Next technique is called the Mikado method. If you thought the brain dump was a bit common sense and messy and you prefer a strict process, here is a recipe you can apply. It's a process. So remember, you want to achieve something like upgrade the ORM or whatever. You write that down on a piece of paper. Start with a piece of paper. It was fine paper. Then you start a 5-minute timer. I like 5 minutes, especially at the beginning, because it's really small, and you will see why. For this, I like to take a big timer, something that will block you, not something that buzzes in your pocket, but something that you will need to stop. And you try to achieve that goal within 5 minutes. Of course, after 5 minutes, the timer will ring and tell you you're out of time, and did you complete your goal? Probably not. Because if you could, then you probably wouldn't have written that goal in the first place. That's something that means that to achieve that goal, first, there are things you need to do that are smaller and that are preventing you from doing that. So when the timer rings, it's very important to stop and think, what is blocking you? Are there subtasks that you could do first that will make it easier to do the main goal? Then you need to revert code changes you did. If you started to try to do that change and you couldn't do that in 5 minutes, revert everything you have. And I am super serious. It is important. If you're afraid to revert, you can stash it, but it's important to start fresh. And that's why I like 5 minutes, because I find it easier to revert 5 minutes of change. I mean, you can redo that within 5 minutes. It's not like you're wasting a lot of things. So we are reluctant to delete things. Pick 5 minutes and revert everything. Then you pick a sub goal, one of the sub goals you listed, and you start over. And you do that again, and again. And eventually, at some point, you will achieve something. You will be able to complete something within 2 minutes or within 30 seconds, whatever, something that is so small that you can do within a minute. Like it's something very, very small. In this case, first you celebrate, like you will get your little dopamine shot when you cross off the thing from your graph. And it's a good moment to commit. So that combines the brain dump and the overcommitting, because it means like you will have less than 5 minutes of work in a commit. So if you're not used to that, that's already a good step forward. And then you pick the next thing to do and you start over. At the end of the day, from the outside, it will look like you're speed running through the code. Like you're flawless, your commit history and the resolution of your problem is perfect. And it's not like the fact that you know in advance what to do exactly. You try and die. You try something, after 5 minutes you couldn't do it, you revert a little bit back in time and you try something else until you find how you can achieve that final goal. I know that it may sound abstract if you never heard about that technique, so I want to show you how it looks like, and I want to emphasize on 2 things. First, you want to achieve something, so you put down some words. There is a ticket associated to that goal with more details. I just want to understand myself what I mean when I put that. I cannot do that within 5 minutes, so I have sub goals. I discover new things that I need to do first, and again. And again, and again. Like at the beginning, it will feel like you're not producing code. And that's right, you're not producing code. And more importantly, you're not getting into a state where things are not working anymore. But with the graph, what you can see is you have achieved the mapping of the terrain. You are discovering what are all the things that you really need to do if you want to achieve this, which usually is unknown at the beginning. And that could explain why you're still working on that ticket after 2 days. Then eventually at some point, you will be able to complete things. So there is a bit of a back and forth, but eventually you'll reach a state where you just go through things. And the more you do little things, the easiest it becomes to do bigger things. And you do that again, and eventually you reach that kind of state. And in this position, you feel really great, because this means you're 5 minutes away from completing the main goal. That's the idea. There is a book, the Mikado method. So I invented nothing here. I recommend you not to read it now, because, well, especially if you're like me and you will think, oh, before trying the Mikado method, I need to buy the book and read it. But I have other books I need to read, so I will put that in my backlog. And in 6 months, you won't be applying this method yet. Instead, I provided you with a recipe here. Try that, see how it goes. You will have questions because there are plenty of nuances I didn't detail here. And this is the moment where I advise you buy the book and you read the book so you can find the answers to your questions. I think it is a more efficient approach. I put you a link of a tool I really like when you want to do that kind of graph online. I use MindMap for doing that. All right. Next technique is about prioritizing technical debt. So it's less about code, but much more about strategic decision and talking with business people, for example. It's called hotspot analysis. And the gist is, when everything is urgent, nothing really is urgent. This is something you may be familiar with if you're really into personal productivity or even project management. There is something called the Eisenhower Matrix. It's a simple tool you can use when you need to prioritize a bunch of things you have to do. There are two ways to, not two ways, but there are two attributes for your task. The first is the urgency of the task. Like, do you need to do that by the end of the day, or it should be done by the end of the month, for example? How urgent is that thing? And then the importance, how bad will things be if you don't do it? Will it be like terrible and you, like, many people are counting on you for this? Or will it be meh, you just like, it will be delivered at the next sprint and that's okay? So you prioritize stuff like this. You put your task here in the buckets, and then you have your urgent, important stuff that you need to do now. The rest you probably can do later or delegate. And eventually what is not urgent and not important, drop it. Like, it will come back naturally if that's really important. We usually have a problem of having too much in the backlog than not enough. That's for prioritizing features, tasks, etc. What about code though? When you work with the Legacy Codebase, you probably have some kind of way to evaluate how bad the code is. A very popular way to doing that is using a static analysis tool, giving you the cyclomatic complexity of functions of files, so you can see where the part of the code that really needs to be cleaned. Problem is, in my experience, when you work with large code base that have been here for a long time, there are a lot of problems to fix. So how do you prioritize them? Do you only take the critical errors that are raised by the tool, and then you have like 2,000 critical issues to solve instead of 50,000? Some tools even give you a maintainability score and an estimation of how long it will take to clean up the code base. There is no way you can, like, don't pause the production of the features for refactoring code. I think it's a bad message to send to especially non-technical people, because they will see cleaning up the code as an opposition of delivering value and features. And I think refactoring as you go is one good way of doing this. But anyway, back to how do you sell the message? Importance is not enough. How bad the code is the importance. Where is the urgency? The urgency, you will find that in Git. And the trick is, if you don't need to touch the code, you don't care that it's terrible. And you can know if you have to touch the code based on the history in your version control. So in Git, for example, we can find the 50 files that we touched the most in the past year. And that's usually enough to give you a good estimation of what are the parts of the code base, regardless how big it is. What are the parts of the code base, the 20% of the code base that is really important to clean up first? And that's the code churn. Here is the command you can use if you're using Git. So you ask git log, which is a gold mine, to give you the file names of the past 12 months, and you remove the fancy formatting. Then eventually you filter out the files you don't want, like the JSON files, the YAML files, the Markdown, etc. You don't really care about these. Then you sort them alphabetically and you count them with unique. Finally, you sort them again in descending order, and you pick the 50 first. That command works on any Git project. It's simple. And if you combine that result with whatever scoring static analysis tool you're using, and you put that in a graph, any graph, you are able to have your Eisenhower matrix of technical depth. Here is an example of Docker engine, which I don't know, and I don't do Go at all. But if I were to help them improve their velocity and deliver faster, I would probably not work on the files that have the worst maintainability score. There is a file that has a slightly better maintainability score, but that is touched very, very, very frequently, and it's the daemon Unix Go. And this file is probably the one I will try to inspect and address first, because I'm sure that this will be the best return on investment for the whole thing. And return on investment, like investing strategically in this to improve the velocity of delivering features, etc. This is a kind of language you want to use when you talk with stakeholders. You can use that kind of prioritization graph and come up with a clever plan to convince stakeholders that you're investing in making your machine faster, because for the moment you're delivering too many bugs or you're slowing down. And that can hotspot analysis, finding which are the hotspots of your code base, help you reduce the work to something you can manage, even if you're working with a very, very, very large legacy code base. Then I'm going to talk about approval testing. And I'm going to actually do a very rough summary of approval testing, because I actually had a whole talk on approval testing. And I've got plenty of people doing many talks about approval testing and the nuances, etc. It's a big topic. But if you don't know approval testing, I want to present it to you, because it's one of the core techniques you can use to recover an existing code base. Here is the situation. What the system is doing right now is more important than what it should do. Sometimes, often, we think that the system is behaving a certain way, but it's probably not the case, or it's very frequent that it doesn't happen. It doesn't behave exactly the way we think it would. So before we start changing the code with our hypothesis in mind, we need to make sure that we understand what the system is doing, so we preserve that behavior, or eventually we can discuss with every stakeholder to understand if that is a behavior that is expected or not, and what can we do about it. And remember, you have short deadlines, and usually you don't have tests. So it's not like you could just look at the test to have a documentation of how the system is behaving. Usually you don't have that. And you don't have so much time to write the test. So again, you don't know how the code is behaving. You don't have tests to explain how it's behaving. If you have documentation, I would be careful, because maybe it's not true. and your short deadline. So you cannot just spend 2 weeks to understand what the code is doing and writing small unit tests on this event. First, you need to have a safety net fast, so you can start working with this code. And Lane, I would get to the questions at the end. Don't worry. So here is my recap 3 steps recipe of how you do approval testing. The first step is to be able to generate an output that you can put into a file. So usually a string. You need to generate a string somehow. So if you have a function that you're testing, you want to cover with test, and it's returning you some value, you can probably stringify this and put that into a file. In practice, you may not have that, and maybe the thing will do side effects, like call an external system or whatever. In this case, that's fine. Maybe you can inject something, some extra logger in your test, and that logger will capture, will consolidate some sort of a snapshot, and at the end of the day, you can take that snapshot after you execute the code and put that into a file. Then, when you finally get your first test working, which is the hardest part, honestly, you will use test coverage. Test coverage is very good for one thing, telling you what you're not testing. Because if you're not testing that, for sure, you need a test here. If you want to touch that code and you know it's not tested, you need to add test. So here, for example, all of the red lines are examples of things that I need to write test for. And how do I reach these lines? Here is where it becomes an art. You need to find how to combine the inputs and the context so you can finally reach that line. Or maybe it's dead code, who knows. Finally, you use mutations to verify the snapshots, which is a too clever way to say you introduce silly mistakes in the code on purpose and run the test again, and you want to see a test fail. If you don't see a test fail, you need to revert the silly mistake you did in the code, and you need to find a new combination that will make that test fail. So if I go back here, say I want to verify that line 17 works and it's covered, but is it really tested? I will change the name of the HBRE string, just to make sure that when I run the test, I got something failing. And yes, this is Gilded Rose Kata. And don't be worried of testing many cross combinations. It's not about the performance. It's about quickly having a safety net of the function that was not tested at the beginning. And you can see that this test, when you can cross combine all of the possible combinations of inputs, very quickly you're able to, it's like throwing paint on the wall to get it covered with paint. It won't do the little edge cases, but very quickly you will get that wall painted. So when you're done, you're safe. Basically, you're safe to start refactoring the code, and you know that you have the safety net that will tell you if you change some interesting behavior. As you refactor the code to implement your functionality, you will understand what this thing is doing exactly. If you look at this code, I don't really know what this whole thing is doing. I don't have all of the specs. What I know is that it should update the quality, and when I provide these inputs, it should provide me the same output, but I don't know what is the rule exactly. I will discover that progressively. But now I can change the code and I can refactor the code, and if I do a mistake, I will have something telling me that. So there is much more about that. I put you a link with much more resources, including the link to approval test. You can go to approvaltest.com, and you will find plenty of tools and resources in many languages. Finally, this technique is, it's not really a technique, but it's an important part of the journey. This is a pixelized picture of artists performing in front of an audience, back when it was a thing, but soon it will be again. And I use this picture because I want to tell you that before performing in front of an audience, these people practiced a lot. And they will be practicing the next show. And it's not just artists, like pilots also practice before being on the field and flying new planes. We as developers, when we're working on production code at work and we have people depending on it and we have like deadlines, features, etc., we're not practicing, we're performing. And because we have short deadlines, no tests, no docs, etc., we get back to our comfort zone, to what we know how to do. And so all of the techniques I presented here, maybe work is not the best place to start using them because you don't really have time for that. Coding katas are exercises that are not meant to be solved. It's always the same exercise. They are meant to be done over and over and over again. There are playgrounds for you to practice things. There are plenty of katas about crafting new code, and some of the katas are about refactoring existing code, legacy code. I've handpicked 5 of them, sorted in a difficulty order. If you never tried a coding kata before, especially a refactoring one, start with the Gilded Rose. It's the most popular one. You will find plenty of resources on the topic. I recommend this one. It's available in many languages. Start with this. And with this, you can practice all of the techniques I presented you. See if that works for you. You can practice different approaches of refactoring the code, different ways of putting that in under test, and see how it goes on this little playground, which is complex enough to simulate some real world scenario. I find it very efficient when we're working with junior developers. We will be overwhelmed by the complexity of an actual legacy application. First, they practice something very well on this exercise, and then it's easier to do in real life. This is what you practice, but when do you practice? If you're lucky, you may have some time in the evening or during the weekend or the holidays to practice on your own time. I used to do that. I can't anymore because I'm a proud father of a little girl. She's a 19-month-old. And so like at 4 p.m. today, I will get her from daycare and I will have to take care of her until 7 p.m. basically. So I don't have time anymore in the evening and none in the weekend to do that. I'm already really, really busy. So I cannot practice on my own time anymore. But my company, they have a training budget. If you're here at the conference today, maybe that's because you're paid by a company because they have to pay some amount every year to train you. If you go to conferences, if you take classes, for example, on learning new technologies, like new frameworks, new languages, new like Kubernetes, DevOps, etc., this is all great. You should invest in learning every year, especially in our field. It's very important. What I'm saying here is if you spend companies' budgets, training budgets to learn new languages, new features, new frameworks, etc., you may be able to use that budget instead some year to do this instead. Hire a coach. Many people, especially in the community, are coaching to train you and your team on writing approval tests, working with legacy code, refactoring, all of these techniques, doing small commits, all of these techniques. You have great coaches out there. And maybe that's something you can propose to your company. Hire a coach for 1 week and get your team trained on working with existing code, because this is a skill that you will need like your whole career. As long as you keep working on code that you didn't wrote and that is in production, regardless of the tool and the language, you will have to work with this. So I think it is wise to spend that budget to train yourself and practice. If your company isn't really into it, something that works in that kind of culture is to set up a meeting. Yeah, I mean, you have so many meetings. What another 1 hour meeting with other developers? What will it change? Do a 1 hour meeting every sprint, for example. And during this 1 hour meeting, what you do is you practice on the coding kata, maybe together, maybe you try to do some mock programming. And there is something called a code retreat. So it's one full day of practice. It's free generally. So in terms of budget for a company, it's only you having to take the day off. You have that on Friday and or Saturday. There is a global day. Usually in November, there is a global day of code retreats. You have code retreats all the year in different countries. The global day of code retreat, now it's remote. You have that on Friday, you have that on Saturday. So you have a great opportunity here to practice new stuff with different people. So it really will be coding this time, different from this conference where you are learning, but I am telling you, which is different from we're coding together and you are doing it. So that's it. These were my 7 techniques. There are plenty more, but I really think that these are really useful. And if there is one technique you never tried before, give it a try. Finally, I have a bonus stage. If you want to go further, I've been working on these topics for a while. I've been in the community also trying to be active for a while. And at some point, I did my own catalog of the techniques that works the best for me for when I have short deadlines and no test, like in this specific context. So I put that in a book, 14 techniques, and I created a link so you get a 30% discount if you want. Compared to these techniques, you will find the Mikado method, hotspot analysis and approval testing, and micro committing. I don't mention the ADRs because I was focusing on short-term benefits. ADRs is nice, but on the mid-long term, like multiple months. Brain dump, it's kind of included in the Mikado method. Coding katas, it's more not really a technique. So you have these 4. I got much more into details and with code examples, and I put much more. So if that's the kind of thing you're looking for to learn, this is something that can help. Thank you very much. I'm gonna drink a little bit and then I will answer Q&A.
Thank you. Thank you very much. That was great. And again, I mentioned this to you earlier, but I really like the thematic way you formatted your slides. It's very nostalgic. So thanks for giving the links to how you pull that off. So yeah, so there are some questions over in the Q&A tab, and then there have also been a few questions peppered throughout the chat. So if you can take a peek at those.
Of course. They are in the slides. Sorry, I see someone ask me to put the link. I'm going to put the link. Yeah, it's in the PDF. So if you want to find the PDF again, here it is. You will have all the links. All the links are inside. All right. I will start with the first. So which one was the first question? Because 3 hours. Any advice for getting a root pass to sort of? I'm not sure if Ashley. No, I think Ashley's question was from before. I think the first question is, how does Mikado method work with estimations when your boss has how long the task will take you? That's an interesting question. It's also one of the arguments of the Mikado method. Once you have the graph, you have something concrete to show at stand-up, for example. If people want to get into the details of why you're still doing this after 3 days, you can show them, well, it started here, and now we are here, and I already did all of that. So I ship an intermediate pull request. So I already was able to ship some value, but there are much more than we anticipated, which is normal. Like spending, like it will take as much time as doing it to figure out what are all the things that needs to be done. So estimation is only an estimation, and the Mikado graph is a cool artifact you can use to share that visibility, which is way better than when you, like even if it's not a perfect graph, it's better than when you have nothing and you just say, still working on it, trust me. So that can help. What's the difference between approval testing and acceptance testing? So approval testing has many names, but acceptance testing, it's something else. My definition of acceptance is the one I know about acceptance testing is not the same as approval testing. Approval testing is the same as characterization testing from Michael Feeders, and some people used to call that golden master. People from Facebook call that snapshot testing. They're all the same thing. It's about you take a snapshot of what the system is doing currently, the current behavior of the system, and you capture that in a file, the golden master, and then you run the behavior again and you compare to what you have captured before, the approved file. That's approval testing. Acceptance testing, you can do acceptance testing, for example, when you write test first, like maybe in a TDD approach also. You will write your acceptance test, like high level, what this system should do as a user, what's my use case, blah, blah, blah. Approval testing is only test after. You need to have the code working before you have the approval test, by definition. So that will be my take on it. Now, on testing, many people have different definitions, especially when you go into unit testing, integration testing. I usually recommend to clarify what you mean by acceptance testing, and you can look up what the people out there are using as a definition. Would you recommend trying Mikado at work straight away, or use the Kata first? It's up to you. I think it depends on your company culture and how you feel. If you feel you can try it at work, do it. That's what I did because my company has like I have autonomy and I can try things. That's fine. Like we're not so pressured with deadlines. If you cannot do that at work, this is where I recommend you don't do it. You keep doing what you're doing at work, and you practice on the side. So when you know how to do it, you can apply it at work. All right. I think I covered all the questions. If you have further questions, the best way to reach me out is on Twitter. So I put my Twitter here. You can ping me on Twitter, and if you don't have Twitter, in the slides you will reach to my website, and you can you can send me an email. You can that's also a good way to contact me. So if you have questions afterwards, don't worry. Awesome.
Thanks so much, Nicolas. Thanks for taking the time to speak. Events like this aren't possible without speakers, so thanks a bunch. And go ahead and stop broadcasting now, and we'll be back here at 3 p.m. Eastern for Marianne Bellotti's talk. So thank you.